So next up, I just want to introduce George Gensure from Uber ATG. He's going to be talking about building on key, keeping your actions and remote executions in tune. Come on up, George. There you are.
Thank you very much. How's it going? Oh, you're welcome to the remote execution block. Let's see. Are we moving on? Good. The quickest slide ever about me. I work at Uber ATG. I am the build team lead. We're hiring, of course, and always looking to have more contributors to Bazel, more contributors to Build Farm, which I'm an author of, and I'm a contributing member to the Remote Execution APIs group as well. We meet on a regular basis and try to discuss ways in which we can make these tools and make this protocol better for all of our users and for all of our use cases. So I'm going to take you on I'm going to tell you a story, and then hopefully we're going to take a little trip together down the rabbit hole of how these things can happen. So to set the stage, I'm working in the morning, and I open up my cool source C++ file, and I make a really great addition and pop back into my shell and invoke my remote build because I have remote resources available to me, and it starts up, and I sit for the next 750 seconds watching this thing tick maddeningly up and up and up and up, trying to build the Docker image that is to be produced and released into our remote system for the following day. I've gotten tired of this. I've finished my coffee, I've finished my breakfast, so I have canceled this operation and decided that there's no way that this remote action can be doing the right thing. So this is my relatively quizzical face. I don't know why the font came up a little bit different, but the hypocrisy of this is that when I gave up on remote, and whenever I just ran this action locally, skipping my expensive remote infrastructure, I was able to complete this thing with its one remaining process to finish in 0.03 seconds total, and the entire action itself only took about 1/100th of a second to complete. Why? Why did this happen? Was any of this information helpful for me in telling me what was going on? If I can go, when I look at an action or a counter ticking up on remote, I assume that there's meaningful work being performed. I assume that there's some execution that's taking up all our time, or that everything should just work. The remote resources are much more powerful than my own. What could possibly be the problem? Who's to blame? Is it the remote infrastructure? Is it my action? Is it possible that I've defined the incorrect action to use with my remote? And more generally, are there characteristics of actions that mean that you don't want to execute them remotely? Is there a situation in which you don't ever need to call the remote system for your action because it's wrong to do so? It's going to cost you more. It's going to cost the company more. It's going to cost the infrastructure more. And in general, it's going to take you longer to get back to work. So the go-to phrase around my team is that the fact that the build is fast, or the idea that the build is fast, is the only thing that grants you the freedom to explore, the only thing that grants you the freedom to look into what you want to look into. The converse of that is when the build is slow, that's a P0. You don't get to spend any time on anything else except making the build faster. So what we say to most of our engineers is you get to do anything you want as long as you don't make the build slower. So in order to solve this riddle, the riddle of the remote execution action that takes forever, we're going to take a little trip into what the remote system has to do and how those things function and what Bazel is doing on your behalf. This will be specific to Bazel. I know a lot about how Bazel works, mostly because I've worked in the remote execution client sequencing. And I also know a little bit about how Build Farm works, so I'll mostly be doing this from the perspective of that, but it'll hopefully be all about sequencing and what events are emitted and what things are told to the client. And then we're going to try and distill those pieces of information into good and bad actions, meaning what can we characterize as something that would fall prey to these systems, and then hopefully give you a little bit of some tools for figuring out or for doing something about this poor performance, and hopefully explore a little bit of the roadmap down the road in terms of improving that tool lifecycle and exposing the ability for Bazel or other clients to react differently to scenarios like my individual action is taking too long, my build is taking too long, etc. So a remote build invocation very simply looks like a Bazel build, specifying a remote executor. Thank you, Bazel team, for not making me specify my 16 flags to do spawn strategies. And the spawn strategy of remote comes in by default. A spawn strategy means a way in which we're going to call exec for all you Linux heads. We define the remote spawn strategy as a procedure that is required for all actions by default. That means that anytime you're going to end up with a spawn, you're going to end up with a shell out from Bazel, you're going to go through the remote execution strategy unless you do something different. So I'll hopefully run through the remote caching and remote execution basics very quickly. The point of this is to compose an action that represents a unit of work that you want the remote system to do, to try to map that action to work that has already been done via the action cache, so retrieving a result that comes down out of that, and then with that result that has individual files of outputs that are referenceable via the CAS, the content addressable storage, download those results. So we go action, digest that action to make a key, get a result, and then take the result files, the result content, and download it. And Bazel will repeat this as often as it can, as quickly as it can, in order to get the entire set of action outputs for your entire build graph. So what happens whenever we miss the cache? In remote execution, a secondary system kicks in that says, we are going to go through the procedure of actually executing this action. And because we have remote resources available to us, we're going to try and execute that remotely. For having composed the action, we knew about all of our inputs. We knew about all of the individual files that went into our piece of work that needed to be done. So we then asked the remote system, do you have all of this so that you can then perform my work for me? It tells you that it does or does not for some mapping of digest, and then you upload those results. After you've successfully ensured that the remote system has those inputs, you then execute the action. And I've got little fancy diagrams here associated with we're sending an execute request, and then we eventually get an execute response back from that remote system. Then we download the results that we retrieved from that execute response, which contains an action result, and put them onto the local file system and continue on the same way that we did before. Hopefully those results have also been cached on the remote side. So that means that we're going through a fairly fancy Rube Goldberg machine associated with one action's execution. And I've got a lot of actions inside of my build. So understanding that from end to end, a single action has to perform composition of those units of work. That takes some cost. We have to go fetch them or try to fetch them from the action cache. We then need to possibly go and check upload missing blobs or check for missing blobs. Perform some number of uploads, then perform an execute, and then perform the downloads. Each one of these things having been broken up serially by the workers inside of Bazel to perform your action. This is in comparison to the default console output. Doesn't it look a little bit sparse now? I've got 3,270 seconds that have been executed on this action, and I don't know which one of these phases he's stuck in. He is definitely stuck in one of them, but there's no clear indication from the command line as to what's going on here. Are we downloading? Are we queued? Do we not have network link? What's going on? So there was a great keynote discussion yesterday about embracing your failures. And I don't want to say that I don't have enough failures, but sometimes I like to go looking for trouble. So I like to translate these things that are successes, these things that are eventual downloads, these things that are slow actions. They're completing, but they're slow. I want to make them my failures. I want to make them my target. So each component of that execution process, that remote execution procedure for that action, represents a unique resource consumption point. Either it's consuming RAM, or it's consuming CPU, or it's consuming remote CPU, or it's consuming bandwidth, or it's consuming the ability to write out to the file system. Every single one of these things layers in, and you're all engineers, so you know where to look for problems, but in terms of giving you introspection into what these things are doing without necessarily providing you the perfect tool to slice and dice up your actions as they're running. Moreover, you're supporting other engineers. They don't always have this stuff turned on. They don't always have the right login. They don't always have the right information either available to them or enabled in their environment. Maybe it's too noisy. Maybe they didn't really want it to begin with. Resources in this situation are exhaustible. This is why I play StarCraft. This is why I enjoy running through electronics and figuring out how I can transfer things from one machine to another very fast. I will exhaust the resources that are being consumed eventually associated with each one of these builds, whether it's my bandwidth or my CPU or the remote machines or the remote queue. They will run out, or rather they will suddenly not be available to me. And for each one of these items, the inputs, or rather the size of the inputs, scale the resource consumption with a degree to what you do. In most cases, either, or I should say this, whether it is a literal translation of an input size, whether you've got a 10 gig tar input for a 10 gig tar GZ output, or you've got a 10 gig tar input for a SHA-1 output, or if you've got a 1 kilobyte input for a 10 gig output, you've still got inputs in between, even if you've just got a program that's generating random bytes to fill up those 10 gigs. Those inputs always scale the resource consumption at each one of those levels, so they are the determining factor. You can make actions that run very quickly. Everyone is capable of this, but it's possible that the action workload that you're requesting just isn't well suited to the particular resource consumption or the particular resource exhaustion that you're going to experience at each one of these levels. And then beyond your control, or not necessarily beyond your control, but certainly making you subject to what the current situation is, there are environmental factors that limit the throughput of each component. Who here builds while watching videos on YouTube? Guess what that consumes? Your bandwidth, your memory, your resources. It's Chrome, so it's like 5 gigs, right? At each layer of this thing, there are competitive factors, either competitive or environmental factors, that are going to limit what you're doing. My uplink to AWS is degraded. My neighbor is attached to my same switch, and he's bottlenecking me. These are sort of the noise in the system, and you can take them or leave them in terms of trying to make decisions about them, but I would say that the decisions are not endemic to your actions. They might change the decision for the moment, but they don't necessarily change the decision for your definition. So we're going to put it to a decision. This is a thought exercise as well as a lesson in how we're going to do this once we know our choice has to occur, once we know at what point along that procedure we have to do something, to make the choice to execute remotely or locally. And that may include giving up on the process and flipping back to local. or giving up on the process and restarting it, or giving up on the process and failing the build. Maybe there's a bad circumstance here that the user doesn't want to be subjected to. Are there any guaranteed scenarios that cut out the possibility of continuing on or making the remote execution? And there's an additional thing here, which is you can make this decision in design. You can make it far before that component phase even starts if you have a priori knowledge of how each one of them has performed in the past. I know that this action takes forever. Therefore, I want to make a decision about executing it remotely, and I want to say no, at least for the time being, at least based on the current conditions. These things are always subject to time, but do we have to come up with a generic perfect answer? And I say no. And can this thing be automated? And I say yes. Big fan of automation in general, especially when it pertains to making split decisions about whether or not to subject your users to more pain. So I've got a whole series of slides here that's going to break down what contributes to Bazel pain, or what contributes to remote action execution pain. And I'm going to try and breeze through them because I want to get to the end where there's some neat stuff. The Bazel concurrent execution model works by starting up, based on your command line, your job specification n. Bazel starts n of these workers to produce the concurrency. That means that there are n worker slots. We have one thread per worker. We have many concurrent uploads and downloads inside of that action sequence per thread. And we have one blocking execution. That is the sequence of operations that we're going to perform. And whether that's remote or local execution, that happens per thread. There is no concurrency beyond this when you talk about Bazel. There is only upload or download concurrency and blocking execution, or rather, end job concurrency. The composition cost is influenced by a number of factors. Bazel takes all of the stated source and intermediate output artifacts and has to compose a Merkle tree on the behalf of the action to be performed locally, or sorry, be performed remotely, or even be fetched from the cache. You pay this penalty every single time you execute, whether you are doing a remote execution or a remote cache hit. These cache misses pertain to file system interactions. They have to be statted, they have to be read, and they have to be digested if we don't have all the information that goes along with them. Those trees are composed individually for each worker. Remember I said the concurrency doesn't shift and doesn't go off in different directions for different purposes for the most part. The Merkle tree has to be composed in sequence and is usually not shared between any other workers because the synchronization primitives for that are fairly difficult. You're essentially maintaining a very large shared tree of file contents, of input contents, and it's a difficult problem to try to keep those things synchronized such that we don't overuse memory. And we can safely evict some of those at some point. The actions and the commands and the collections of digests are all retained per worker. That means they're in RAM. They're sitting in RAM in the worker for each one of your n jobs that you execute. Suddenly that, dash jobs 3000 is looking a little bit thin in terms of resources. The find missing blobs request is the sort of the nail in the coffin here. It's the last request that you have to make after missing a cache where you have to compose a gigantic list. And I'm talking gigantic because I've got tens of thousands of inputs in some of my actions. Most of them are repeated, but I have to ask about this every single time to the remote system to determine whether or not we can execute. And again, memory. So I put together a special slide on memory. This is the nature of memory in Java. Java is what Bazel is written in, if you hadn't guessed that already. Heap is all of Java's useful memory. There's almost nothing stored on the stack. You wouldn't want to store anything on the stack. The stack looks like 128 or n concurrent jobs worth of storage so that we can call into different functions. All of remote execution's content is retained in memory for each one of these workers. That means if you want to do more remote stuff, or you have more inputs, or you have more outputs, excluding the output content, most of that's just written straight to disk, you are going to consume memory. And in Java, memory at the top of the heap when you've exhausted all your size, and everybody here has run the -MX option to increase the available Bazel memory for their JVM, at the top of the heap, that memory translates into CPU because the GC starts kicking in and starts spitting out things from Eden and starts spitting out things from the old collections of things that I don't really know about for GC. And you can roughly say that memory is CPU in Java as you reach the top of that heap at a very unequal ratio. When I get to the end of builds, in fact, we've added a special option to record this information from Java and parse it out and print it out for our users. We tell them, at the end of our build, your 300-second build spent about 40 seconds in G1 GC, full GC. These next couple of slides are more about how the remote execution system itself wants to see data. This is not an exhaustive list of what the preconditions must be satisfied for on the remote side, but hopefully this is a view into something that we can perform useful experiments with in terms of making your build faster from an interception standpoint. And I'll explain what that means, I promise. Basically, the remote Bazel side wants to see all of your inputs available to it at the time that you start your execution. This is sort of hard to get around, right? We need to know about all of those files. We need to know about that entire tree of inputs. We need to know about that command before you start your execution. The missing contents have to be uploaded, which means they have to be read completely. I see another resource possible here. I see 2 resources possible depending on how bad your reader is implemented, but my guess is that it's implemented pretty well, and we're going to suck in all of the content for all of the inputs that we had missing on the system completely for an upload. We're going to consume n number of IOPS based off of your source file system, which might not be too fast. So let's get into what that cost means. Obviously, or I hope obviously, the upload cost is going to consume bandwidth to your remote endpoint, in addition to consuming the I/O on your local disk. Hopefully those are being consumed in some sort of a streaming fashion so that we either have these pieces of content ready to be uploaded or we're performing them in a way that isn't going to put a lot of stress on memory. But these are subject individually to the remote timeout. And if you haven't played with the remote timeout, play with the remote timeout. Make sure that you make these requests come into you as fast as possible. The default remote timeout inside of Bazel is 60 seconds. Does anybody know what the recommended default remote timeout is for RBE instances? 30 seconds? Anybody else? All right, this might be going back a ways, and I might be wrong about this, but the number is 3,600 seconds. Each action execution is guaranteed based on the default config that was distributed with RBE as a recommended environment to take up to an hour in order to accomplish its goals. That means that it was dealing with possibly n by m in terms of n concurrent actions by m missing inputs, because these things are uploaded in parallel. The Bazel client tries to upload these things in parallel. If you have 10 inputs that are missing on an action, it initiates 10 requests immediately. That worker excuse me, is performing 10 uploads concurrently. Does your bandwidth look like it's thinning out a little bit more as well? Specifically, excuse me, in the case of extremely large builds, you can very quickly exhaust the ability to complete your upload within these individual remote timeouts. The uploads themselves actually happen in very small chunks. You don't spend a lot of time waiting on network I/O in order to just perform one particular action, but excuse me, there are a whole lot of IOs happening here, a whole lot of individual communications. There are a whole lot, the Grace Hopper likes to use the how many milliseconds in terms of distance there are from here to the satellite that you want to communicate with. The 16K is my lingua franca, and your 3 gig Docker file is the communication that I want to make to the satellite. There are a whole lot of transfers that need to happen here, and they're going to be happening at the same time as all of the other uploads. I apologize. I thought I had my cold done last week. So as I said, play with remote deadline. You play with remote deadline and you can't get your uploads done completely. I want to know about it. I'm very curious to see, when you tweak these things, when you stop making yourself subject to them and you start making yourself in control of what the remote is really capable of doing inside of reasonable timeframes, you might get some different answers. You might get some loud seg faults. You might get some stack traces. Hopefully I can improve that as well. So the upload cost, so I've given you a lot of bad information about the upload, but the good on the upload side is that Bazel eliminates all redundant uploads for an entire invocation, with the exception of an entry that you tried to put into the cast disappearing very quickly after you uploaded it. Bazel will not try to upload the same thing across all the instances at the same time. Progressive uploads helps this, and I'm happy to say that I was the contributor on progressive uploads as well, that we will restart requests, restart uploads, and restart writes if that deadline is exhausted. That's the reason I want to know if your deadline actually changes, whether you can actually upload something. Progressive uploads just says that if you're making progress along your upload and you just happen to have exhausted bandwidth or exhausted the ability to time slice into your network card, you won't be charged with the destruction of your build and the end of life as we know it. The upload set is non-idempotent, and I might be using that word incorrectly, but I'm pretty sure that what happens as you accrue inputs on the remote side is that it amortizes down to 0 time or 0 uploads required. The only likely upload that you've got to do as a part of a novel execution or a novel action, something that you've changed, is literally what you've changed and maybe the action definition and a couple of directories and the command. And then the last part of this is, and this is specific to build farm because I don't know whether this was present on any other build system or remote system, is that competitive uploads, meaning me uploading my 3 gig file and you uploading the same 3 gig file and 3 other guys uploading the same 3 gig file, they'll actually signal one another when one of them wins the race because he had the better network card. And we'll know that the remote system just has that content and we don't need to continue uploading it in any regard. Similar to this, and I almost left this slide out because, well, we'll get into reasons. So the same problem occurs on download. And this is where I spend most of my time because action cache hits don't consume any upload for the most part. They're a single request to determine whether or not you've actually got your output. If you've got your output, then you immediately start getting into downloads. And these downloads, again, consume bandwidth to your remote endpoint. I should say from your remote endpoint. Again, the same situation with uploads happens with downloads, but they're outputs. So they're like almost necessarily bigger. If they're not bigger, there's something wrong with your action because those output files are downloaded in parallel. They're consuming all of the bandwidth. And that literally means if you have 10 files that you produce on a single action, those 10 files are all downloaded. There is no throttled scaling factor on the client itself to prevent you from exhausting your network resources. The standard out and standard error that the action produces, if it produces standard out and standard error, and I'm looking at you, Wix, with your 600 megabyte outputs, they also have to be downloaded because they have to be printed out to the console. There's no way around this. The literal output of those processes, if they're not printed out to the console, it doesn't make it look as though it was magic. It doesn't make it look as though the action actually executed. If you don't see the output from your fancy process, why would you ever think that it ran? So Bazel delays How did I want to describe this? Bazel delays successive action evaluation by default. And my by default here is obviously builds without the bytes does not factor into this. But builds without the bytes does not solve all of this either. So what I mean by successive action evaluation is that worker is blocked until your download completes. Maybe you're not going to use the download. Maybe you're going to turn around and perform an execution. That's literally what builds without the bytes is supposed to perform. But sometimes you actually need those outputs locally. You might have those systems used as remote mechanisms, or sorry, remotely produced outputs for locally executed actions after the fact. And in those cases, you're still going to pay the penalty. And you're going to pay the penalty not in the action that produced it, not in within the scope of the action that produced it, but within the scope of the action that consumed it. You're just shifting work around, assuming that you're actually going to use these things locally. Now, I know that the other case is that you don't produce anything locally or remotely, or rather, you don't produce anything remotely that you use locally, but sometimes I just want to produce an actual artifact. Sometimes I just want to see that artifact on the file system after I'm done. Sometimes I want to be able to run that maybe outside of Bazel or transport it into a package manager. Sometimes people need to do things with their outputs, and this is where you pay the cost. Obviously, progressive downloads require or rather, progressive downloads are required to get past the remote timeout. Again, this was part of the reason why RBE had a 3600 timeout, because we didn't have progressive downloads in the version of Bazel that it shipped with. So this is the end of the discussion about what the client is doing. We know about its resource consumption, right? It's using RAM, it's using memory, it's using CPU, and it's using bandwidth. We want to now focus on what information is being reported during the actual execution. During the execution, the client is bored. During the execution, the client doesn't have anything else to do because he's literally sitting there waiting for the remote side to do something. So along that path of performing those executions, we have some typical, and these are not required. You don't actually require any of these except for the completion. Status emissions from the remote system. And these are exemplified in Build Farm. You can go check out their code. The other thing about this is that we try to only emit these statuses once so that you can use them as a phase sequencer as a client. You will only ever get one initial unknown representation. That's literally an empty operation that just has an identifier so that if you want to reconnect with it later, you can do so. That's hopefully the fastest thing that's returned to you, and that facilitates connection loss, weird situations where the client decides that he can't actually access your operation and needs to resume that. Next step is cache check. There's any number of points at which the operation might have been stalled, and some other operation might have completed that action. We want to know about that message and figure out whether or not he's proceeded. The queued action says that the action is validated, it's ready to go. It's in a state where our workers are going to pick it up, and we're just waiting on them to do so. Then workers end up reporting that they are executing an action. This is a do or die moment for the most part. Once you start an execution, you will either fail with a timeout or fail on the worker or complete. That situation will only be resolved with a completed status change. The action results, or rather the action at that point has results available, and they're cached in the system if they don't. There are two fields in there that are of slight interest to you. The queued operation, or the queued state doesn't include input fetch time, so there might be some time that for a piece of work to have arrived on a worker, but it hasn't yet begun execution because it's trying to download inputs. Fortunately, the ActionExecuted metadata, which is tagged along with every single action result, again, for Build Farm, can't speak to any other systems, and identifies profiling information for how long that operation sat in the queue, how long that operation took to execute, et cetera. And this is neat because this is retained as accounting information, so you can actually get this even on a cache hit. You can know how much time you saved, and that's going to become important. So what have we done here? We've said that we've presented a whole bunch of information about how this action has to execute. So we are now armed with, if we had the right tools to measure these systems, armed with all the resources and all the knowledge required to make the right decision about whether or not we should be executing remotely, hopefully at every single stage here. So a simple characterization of a good action, regardless of the state of the system, is that it has a 1, meaning a 1 to n to 1 ratio of time for upload, meaning it's a fixed cost or a relatively small cost pursuant to the novel inputs that you have, an n cost, meaning an arbitrarily long time for execution, because you want to save something in terms of the remote action execution, and then a relatively small, or a small considering the size of the upload or the size of the novel change of the action, download time. Because when we shrink out and destroy the upload and execute time, we end up with a nice fixed constant or fixed low value download size. If we have a high percentage of change for novel inputs, what that means is that if I change one line, I probably get a whole bunch of other pieces of content changed, and there's nothing that's out of bounds in terms of the output that can produce this. And the examples in this case are code generators, compiles, unit tests, anybody who runs succinctly and benefits from remote execution. So what's a characterization of a bad action? Now that we know that if we change a whole bunch of inputs, we want to reflect that change in large swaths of the output set. We end up with a couple of different ratios, and we can just sort of permeate what we had before. We always end up with an n execution, right? It always takes some amount of time, probably pursuant to the input size. A really bad action might take very small time and might not vary in the execution size, but I'm going to forget about those things. Those are basically random number generators with tons of input files and no output files. Those ratios look like n to n to n, 1 to n to n, n to n 1 in terms of upload and execute and download. Essentially anything that the prototypical example, or at least what provided us with our Führer at the beginning of the presentation, was an archiver being done on behalf of Rules Docker, who was taking my one source file that got regenerated, and he's changing a very small sliver of the input file, and he's got the entire Ubuntu 18.04 image underneath him. There is no way that my input file could ever change this other thing, but I'm going to be saddled with the burden of how much that costs. And I like to pick on Rules Docker, and I actually put up a nice change request to help deal with this. The last couple of things I'm going to go through are remote scenarios, meaning you are literally performing slow or spotty downloads or uploads. Your link status is probably bad. Your queue depth at the time that you wanted to perform an execution might be bad. There is no way right now through either the remote execution API or or any other subsidiary out-of-band API to convey that information to the client and say, now's a bad time. I just went through a really bad breakup. Don't talk to me. Don't try and execute anything on me. The other things that we could see include memory contention and CPU contention on the workers themselves. These things are a little bit weird. They're sort of out of our control. They relate to sharing these things and keeping more work than can possibly be executed, or rather more work than is traditionally a good exercise in doing remote on remote. And then obviously there's remote bandwidth exhaustion. Maybe either the links there are degraded or they have not yet scaled up to what they need. So I'm running really quickly through the tools that we've got to choose this. And this is how this relates to a couple of pull requests that I just put out recently. The action interface for dealing with this, for making this decision beforehand, for knowing that your action is bad beforehand and making a decision not to use remote, is to specify execution requirements, no remote. This is documented in the conventional rule tagging in common.tags on the gen rules page of Bazel documentation, where it has local and no remote and a couple of other common tag definitions, where the spawn strategy takes this information and then immediately changes its behavior whenever it performs an execution. These tools are the worst because the tags attribute is available without specifying it on every rule. That means that when you make a rule, whether you knew this or not, you had a tag argument or a tags argument. That tags argument is an arbitrary array containing an arbitrary set of strings with no validation and no documentation associated with whatever else is in there, but they do reference local and no remote. But these things aren't automatically enforced. The rule consumption of these tags is not consistent across things. And guess what? For every Starlark rule that you've ever made, if you didn't take the tag and look at it and see if it contained the word local and transfer that into an execution requirement that you did a ctx.actions.run or run shell or run whatever, you're not conveying that information. My tag specification is useless, and I can't actually control what you're doing. So I've got very little time left, and I've got tons of slides left. So what I want to do is run straight to the end. I want to say that we can locate bad actions by looking at the critical path that we perform for our build, but that's not the end of the story, because we've got so much concurrency going on that we're probably going to be fighting with other processes. You can use Bazel profiling to do this. My documentation is a little bit out of date because I didn't realize that Bazel Analyze Profile is broken in the current build. You can't actually switch back into the old really cool static web page that I got. So I put up a Chrome trace of a fairly large build that we have, that I have here. And it's got a nice flame graph associated with the actual action execution with its mnemonic, an action completion, which added a layer and didn't really add any information, and a specification of what it was doing in remote. I don't know how to zoom in on this view. I couldn't figure out how to do it before the presentation, so you guys get to do that and take a look at how much time is being spent downloading outputs or fetching action results or pulling in anything else that you need associated with remote, because that's all documented in the lower phase of this. This is extremely noisy. It has terrible sorting. It had terrible sorting in the old interface, and there's no real way to say, here's an action from start to finish. What did we get in terms of a breakdown in time? You can also use the remote logging interface. This dumps a gigantic protobuf file for every single request that was made, either over BES or over gRPC. Ola hates it whenever I remind her of this tool because it's sort of fallen out of date. It's a predecessor, or it's a thing that came from V1. But there is a Bazel repo, a Bazel build repo to provide information on how to get information out of that. Won't even go into that. Won't even go into this. This is something that I'm building that I'm going to throw away because I saw Paul Johnston's talk the other day on his UI and it looks fantastic. Hopefully we're going to get ourselves integrated. Hopefully I'm going to get the data points that I want, because he's also intercepting remote execution requests. And he is able to present a much better view than I ever could in terms of log playback and in terms of actual action definition with durations on those things and individual counts of the requests that went in and how many, and based on a log view and a timeline view, how much bandwidth was being consumed at a particular point in time. The interceptor in this case that I'm looking for has features like an action blacklist. I want to be able to say what happens in this case where I want to delete or where I want to forget about trying to execute this action remotely, where I want to throttle bandwidth, where I want to limit the blob sizes that you can upload, where I want to limit the total action time and cut that out of the mix and prevent you from actually waiting for an action that's going to be beyond some point in time. So I had some adaptations to rules Docker, and here's a call to arms to all the tools developers, and I hope the Federation guys in the room, because maybe we can enforce this in terms of a standard. Everybody should be transferring tags, content, into execution requirements. If you're not doing that, you're giving me rules that I have no control over. You're giving me the ability to exhaust my remote endpoint without patching your code. And I've done it on Docker, and I'll do it on other repos, to transport those things into controllable entities to decide whether or not they want to execute remotely or not. So rules maintainers, please do that. Bazel team, please make it automatically happen under a context. I don't think there's any reason why we can't take the actions object and have that come in for this automatically injected feature and just specify, at least by default, at least without an override, at least without further munging the data, that you get local executions if you want them. 30 seconds, great. So tangential discoveries. Critical path has been broken. It's been broken since we released a remote metrics piece of information that goes along with uploads inside of Google. The particular event to present all of this information was never emitted, and it was never told to the logging subsystem. I fixed this. I put up a PR. I'm anxious. I'm excited to have it updated. The only reason that I noticed this was because the BES content managed to not be turned off, and I found a whole bunch of zeros associated with my my remote attribution information. And the whole world will change because we have builds without the bytes, and we have race the remote, and we have an execution graph API that might work, and that's it. There's lots of future work. I want a better hint from the remote system to the client to tell them not to perform an execution. Right now, we're doing this in very roundabout ways. I'll fail a whole bunch of requests that I know are going to be interpreted or expected to be interpreted as transient failures, and then I'll kick into the retry. So all of my clients have to fail to retry. I want real associations between mnemonics and action IDs, and I think I can do it based on the BES input and based on intercepting all of the action messages that get transmitted to me so that in my tool, I can have a critical path list that I can just click through and see here are the remote requests that were performed as a result of this. This is why it was blocked. And then I want real transparency by default on the Bazel command line into what an action is doing on that line. Why is it running for 600 and 1200 and 3600 seconds remote? How do we convey that information? So that's my rant and my talk, and I hope you learned something and hope it was good for everybody at least a little bit.
Thanks, George. That was great. I actually heard somebody in the audience say, oh, it's good to hear. We're going to break in a second, but we're going to give a chance for some questions. I know that the people from the Bazel team and remote execution team are in the audience, so I think this is pretty powerful. So we got about 2.5 minutes. Eitan?
Eitan from Google.
Eitan.
Hi.
Did you talk about dynamic response strategy? I mean, it's not the best way to solve the problem, but it is a mitigation.
So I don't have control over my back remote, but I'm pretty sure that's what I called race the remote, right?
Okay.
That's where you kick off a local execution and you kick off a remote execution, and whichever one wins, wins. Except if I did that for my 3,000 concurrent local executions, I think my computer would melt. Or at least the Java process would almost definitely crash. Yeah, no, I like it. I like the idea. What I wanted is to adapt that into a condition where I say, no, the remote time has taken way too long, and I'm just downloading outputs. And I've already seen that the execution on the remote side only takes 1/100th of a second. Why don't I just do the remote? Because that execution included ingrained embedded I/O time that already did the output. I want to kick that system in after a time. I want to make that system a little bit better in terms of making the decision of when to do that.
George, we got just 1 minute for one last question, and we can also talk right after this.
I'll talk repeatedly and at length.
Yeah. Hi, I'm Sergio from Lucid Software. I just wanted to clarify, I believe there was a default tag propagations thing for Starlark rules that was merged recently. Mm-hmm. I don't think it applies to like native rules yet, but for Starlark rules, it should be automatic now.
The good news is that most of the native rules already support this. Yeah, thank you very much. I wanted essentially to make sure that not only do rules maintainers know that they don't get to omit these things, and this might like sort of provide a tacit response. But the other thing is that a lot of people provide implementations in the form of existing impl calls, right? They make a whole bunch of different suites of, and I can think of a couple examples in the Bazel tools repo, SHA-256. SHA-256 is a great action to do, guys, on a remote. Those actions are just sort of utilities. So it's a skylib thing more than a default thing, meaning the action may not inherit all of the right properties. And even better than that, some options, some implementations, including rules Docker, allow you to specify tags to override passed in with the worker. And if you were to omit any of the local tags in that case, you wouldn't get the benefit of turning off the execution local. But I'm excited that that's incorporated. My 1.2.1 version doesn't have it, but maybe the 2.0 release will cut with it.
Well, this is great, George. Thanks so much.
Thank you very much.
Thank you. We'll talk a little bit later on. There's lots going on. So